everyone. My name is Olena. I work at Meta Labs, and I am from Crypto team. I'm working applied cryptography engineer. And today I want to talk something about on hype, quantum computer. So, do you hear about quantum computers and how it's dangerous? Is it interesting for you? Right? So, question is, what do you know about quantum computers? Okay, let's start. So I prepared some agenda. We will start from introducing, and I'm making for you some course about how quantum computer works, because I think it's important. Without this, it's really quite complicated to understand some algorithms and everything. So I promise it's pretty understandable. So after quantum computer crash course, we're going to talk about quantum cryptography. Different types of quantum cryptography. Quantum key distribution was very impressive. Short-order growth algorithms, as usual, is classic. Post-quantum algorithm, cryptography, blockchain, and how it's work, everything in blockchain. Okay? So let's start. They have long been an opinion that with the advent of quantum computers, the world will have to recognize security method. So if you look at quantum computer and classical computer, different between them is the quantum computers based on physics law. So let's take a look that why we're going to interesting in this topic. There is a Moore's law saying that amount of transition per circuits is grows exponentially, but in some moment in time it stops growing. Do you know why? Because right now transition is like about less than HIV virus size. So that's why people probably will be interested in quantum computer. And let's look at advantages of classic computer and advantages of quantum computer. So classical computer is, like well developed. It's easier for humanity because it's a lot of technology, a lot of existing algorithms based in a classical computer. It's a lot of advantages, yes, but it's also a lot of disadvantages because of classical computers can kind of have a speed limitation. Also, energy consumption is like we need more powerful computer, and it's not need more and more energy. And a limitation in simulating computing system. To simulate quantum computer, it actually needed really, really powerful classical computers that's not very official. So that's why people thinking about quantum computing, and let's advantages that we can use parallelism, of course. I'll explain how later. Speed, that of course quantum computer should be speed. Should be, I don't know. And quantum security, of course. So, but disadvantages is that it's going to be expensive. Currently it's expensive because of big company investing a lot of money. But another problem should be hard because of entire algorithm, quantum algorithm is for classical computer, and now we should learn physics and starting implementing something with this. And I make a slide where you can see difference. So classical computer have one state. So it's a 1 or 0, and only or. Quantum computer is existing simultaneously in a different state and uses this formula. And qubits, it's a kind of like bits, but it's like quantum bits. So what do you see in this formula? 0 and 1 is a basis. So, and alpha and beta is kind of amplitude what we'll choose, depend from what polarization you want to use. Also, qubits in combined state together, and qubits have such preference like superposition, entanglement, and interference. Let's take a look. What is this? So that's how looks qubit. It's kind of in three-dimensional state, and arrows show with what probability after measurement qubits will get will be output. So wait. Oh, yeah. Qubits have superposition. Superposition means that he can be simultaneously in couple state. So also you can take a example that you can be simultaneously in a different city in the same time. For example, Lviv, Kyiv, Odessa, Dnipro. And you can do simultaneously in the same time different work. But you see the percentage, it's probability. So for example, my main work in Kyiv and I do something in Lviv, what most likely I will do faster? Work in Kyiv. So this probability depends from polarization, from spins in an electron case, and you see this arrow, and this arrow closer to 1. This means that this qubit will be 1 most likely than 0. And this is actually alpha and beta. It's where this arrow show what's close to 0 or 1. Sorry. Next is entanglement, that qubits by itself is independent, but when qubits met with another qubit, they head out together, and they become dependent to each other. And now we wouldn't have the same probability like in previous slide. Now probabilities are adding, and we will get kind of probability distribution. Clear? Okay. Now about interference. The way how I show qubits, it's a beautiful visualization. Actually, qubits look like waves. It's like photon, for example, yeah? And after entanglements, we use interference, and doesn't matter how much qubits you will have one way, and this way function will show probability distribution of all qubits. So it was kind of a little basic about quantum computer, how it works. And let's start discuss about cryptography. So modern cryptography security relies on several basic pillars: integer factorization, discrete logarithm, and elliptic curve, discrete logarithm, and another. I just choose the most important. So let's take a look at the quantum cryptography. Quantum cryptography refers to various qubit security methods for encryption and transmission, secure databases, and naturally occurring inimitable laws in quantum mechanics. It's a general definition. But the most interesting algorithm, I think, is quantum key distribution. Because if you want to send private key, Alice want to send to Bob, they need a bunch of protocol to do this. It's a kind of hard. It's a cryptography question, but with quantum computing it's different. It's much easier. So you see Bob and Alice, and Bob want to send private key to Alice. And in this case, private key will be polarized photon. So he polarizes photon. It means like choose direction, what I showed previous slides. He choose direction and send Alice. And if will not steal private key, listen private key, she want to take a look. If she look at this polarized photon, she will immediately change its state. So Alice and Bob will know. So let's look how it's work. It's a double slide experiment. It was made in 19th, I don't know which year, by Young. And he discovered electron behavior and thinks that electron can be a wave and also like an element. So if you take a look at the first pictures, you have a laser and you have 2 holes and a wall. And you like push a button and laser go, or one hole or another, and you expect to see 2 lines. Yeah, it's naturally. But electrons kind of have wave behavior like photon. And if you push a button, if you even throw one electron, he will simultaneously be in all possible states. And the thing is that this state of electron change depends from observation. So if we put observer here and make this experiment, this will be this picture. If will be not observer, state wouldn't be changed, it will be simultaneously, this will be second picture. That's why Eve can't just look at the private key without any changes. Okay, let's talking about the most popular, I would say, quantum cryptography algorithms. And is it some of my favorites? Quantum coin flipping. It's easy. Imagine that you and your friends want to go to a Beyonce concert or Taylor Swift concert, and you need to flip a coin. How to do this if they don't trust each other? Because one friends like Beyonce more, one friends like Taylor Swift more. So quantum cryptography help, or zero knowledge, of course. But let's look at another way, quantum cryptography. So let's make example, Bob and Alice. Bob creating a sequence of qubits. He polarized them. He had two bases. It's a vertical and horizontal basis. And depend from which basis he choose, depend what behavior will be in photons. So let's imagine that he choose horizontal, like x and y coordinate, and he makes some sequence and send just Alice. Alice don't know anything about how polarizes photons. He just take a qubits, and what she do? She choose between bases two. He choose vertical or horizontal. So what will happen if, for example, polarized is y coordinate, and for example, Alice choose x coordinate? It will be 0 because of light. But situation is, what if she will choose vertical? So in physics, if this happen, this will be 50-50, that proton will be polarized like y coordinate and x coordinate, yes? So it's after when she make a measurement, she told assumption what basis Bob used, and then Bob open his sequence and open what basis he used, and Alice can easily check is it his camera or not. So that's probably go to Taylor Swift. So two the most popular algorithms in quantum cryptography. It's a short algorithm, and this algorithm is most effective with difficult factoring, a large number, and discrete logarithm, and he's excellent with decipher, RCA, and encryption. So let's a small look how it's work. It's work pretty okay. Sorry. We have 4 steps: quantum Fourier transform, modular explanation, period finding, and classical post-processing. Short start from finding periodicity. Periodicity doesn't require to have quantum computing. Here, break a number for periods. Make a post-processing, like finding common division, and then where we use quantum computer, it's actually quantum Fourier transform. So where we use superposition and everything. And then we also, in modular explanation, we use quantum parallelism. Because of different state, we can simultaneously run this. Yes. Next, Grover's algorithm. It's actually, shortly, it's efficient brute force. Grover's algorithm excellent work with hash, with a big database and everything. It's kind of work the same as like instead of periods they have amplitude. How to find amplitude is have broke this amplitude. It's the most incredible fact that speed will be square n. So n is all possible variants. What can be? So he faster twice. Yes. So let's take a look about post-quantum cryptography, because of post-quantum cryptography actually used in a quantum computer and a classical computer. Post-quantum cryptography actually help to protect existing protocols from attacks, quantum computer attacks. And the most popular is lattice-based cryptography, multivariate cryptography, hash-based cryptography, and other. Currently in blockchain, and I saw a bunch of cryptography article, a lot of people try to implement lattice-based cryptography. It's Um, all task is in a complex theory. So it's an NP-full task problem, and it's a different additional sub-problem. And the way what quantum computer is solving, it's a fast multiplication. He will like not NP full problems. He will mostly I don't know if you know, it's big class problems. It's kind of like logarithm multiplication factorization. But not every algorithm he going to solve. So lattice-based cryptography based on vector fields, and it's existing such a lot of different way to present vectors and find like basis vectors to him that not even quantum computers will able to browse this. But it's quite expensive algorithm. It will be long. Let's take a look blockchain and quantum computing. So where's potential problem is? It's a hash, 256. Breaking a hash probably will do Grover's algorithm. So let's find how fast he will break this. Just take all possible combination, 2 power 256, and let's take a square root from this. Square, and we will get 128, yes. So to increase security, we can just take 512, yeah. So next is elliptical digital signature algorithm. It's excellent show algorithm that actually work with this. It'll break this blobs who have a bunch of hashes, and consensus who is so sensitive for, who is based on a quantum cryptography assumption could be sensitive for any quantum attacks. So what will happen if we just switch our blockchain to quantum blockchain? Of course, change security. Security will be increased. Consensus will be way faster because if we have a quantum computer like not everything in mining and everything will be validation will be way faster. Everything will be quantum resistant cryptography because if we make a like somewhere leak when we left some algorithm was not quantum resistant, it could be a trouble. And quantum blockchain. So what I would say it should be fast. I don't know. So let's come back to question: does it have a future? I don't know. I really don't know because building quantum computers is really complicated task. First, it's expensive. Second is that qubits is so sensitive for any observation. It could be like sun, X-ray, what can change entire state. It could be different. So scientists have a kind of idea how to help, how to predict this. It's like they wanna make quantum repeaters every couple miles, but quantum repeaters, it's quantum computers themselves, so it will be kind of expensive. Second, scientists don't know how to control more than 300 qubits in the same time. They kind of, for breaking some algorithm, it's need minimum 3,000 qubits. They didn't solve how to do this right now. And they actually tested Shor algorithm, Grover's algorithm. They tested on a couple qubits and they proved that that works. So I don't know, guys. Don't run and change every crypto algorithm right now because it's minimum 10 years. So, and thank you for listening to me. And you can follow me on Twitter, give me question and Telegram and everything. So, question. What? Who knows about quantum here? Don't know. I don't know too. No, it's a new topic, and I think it could be a lot of research here. It's like in zero knowledge. Do you remember a couple years ago, zero knowledge was in general? Now it's like different proof system, different commits, different signature. You know, it's a topic where you can grow, but we should wait. when first quantum computer happened. I think such company like Amazon, Google invest a lot of money in such research, and that's why they make such a big hype around this topic, because of their money. They want to, like, people take a look at this. So please question. Um, when I'm preparing for presentation, I really read physics books and kind of a lot of formulas. But is this some book what my coworker recommended me? And I didn't read it yet, but he actually says it's in a high level explaining. It's a Quantum Computer Science Democratic Aronson. It's a Aronson. It should be, yeah. So, questions? We have a time.
Do you think it's inevitable that practical quantum computers will actually become, which can break like RSA or these images computation?
Yeah, it's in practice, no one don't know what's going on. But I saw some Google research developers presentation, and they have a lot of open questions. You know, like if we have computers, they kind of look the same. They kind of work the same. They can have different software system, but they have the same rule how it works. Quantum computer couldn't be not the same. Different projects have different idea how to build project. For example, we can use first question, what we can use, electron or photons? They have the same behavior, but electrons have spins, photons have polarization. And what's interesting is that if we take entanglements, two qubits, and send in different way in the universe, and then some of electron choose what state he wanna be, in this time, another electrons choose spins too. It's a kind of theory for solving teleportation. Interesting, amazing. So, thank you.